Hi, my name is Kayla Brogan, and today I will be presenting to you an article titled Surviving Coral Bleaching, Parietes, Growth Anomalies on the Great Barrier Reef. This article was published in 2014 by two researchers from the Marine Science Institute of Australia in Queensland, Australia. Did you know that over 90% of the Great Barrier Reef suffered bleaching in 2022? This was after the reef's fourth mass bleaching event. Figure 1 to the right shows the detrimental effects of bleaching through a comparison of before and after pictures of a colony in the Great Barrier Reef. Coral bleaching occurs when water temperatures are too warm, also known as thermal stress. Corals bleach when tissues expel their algae, causing the coral to turn completely white and lose its natural color. There is also great variability between how reefs respond to thermal stress. Environmental factors affect mass bleaching events and coral taxa resiliency. 3 include 1. Calm ocean conditions versus violent conditions, 2. Anthropogenic stressors such as sedimentation, pollution, and spillage from human-induced activities, and 3 being poor water quality as a result of anthropogenic stressors through acidity and spillage. Figure 2 shows examples of environmental factors such as anthropogenic stressors that cause reef bleaching. The effect of bleaching in the cores of corals can be tested through growth characteristics shown below. The 4 include annual linear extension, annual density, annual calcification, and annual luminescence. Annual linear extension is the outward development of coral skeleton toward the edge of coral colonies. Annual density is the average threshold for the number of live coral heads. Annual calcification is the rate at which reef-building corals lay down their calcium carbonate skeletons, and annual luminescence is the protective layer of algae which cover all corals. Figure 3 to the right shows X-ray prints of coral cores showing growing characteristics before and after bleaching events. Table 1 below shows the collection details of coral cores including reef location, depth in meters, colony height in meters, total number of cores collected, and included in growth analysis. These are the 4 sites that were mentioned throughout the study. Review of literature. Carelli and Norris, 2009, measured linear extension, density, and calcification in the cores of the 4 different reef sites. From the 1998 coral bleaching event, found it took sites 2 to 3 years to recover with low anthropogenic stress. Canton in 2010 found a 30% decrease in linear extension rate since 1998 in corals throughout 4 different sites. Dialovo and McCulk, 2013, from the 1980s to 2000 saw a 10% increase in coral calcification in the Great Barrier Reef. McIntyre and Smith, 1974, while measuring only 2 growth characteristics, decided that they could be seen clearer through the coral cores in an X-ray. The gap in literature is that not all 4 growth characteristics were tested in each study. However, in the 2010 study, when this article was published, they used all 4 growth characteristics, which makes the study special. The purpose of the study is to determine what, if any, signatures of the 1998 and 2002 mass coral bleaching events are evident in the annual growth characteristics contained in the coral cores of apparently healthy reefs from 4 different sites: Nelly Bay, Pandora, Rib, and Myrmidon in the Great Barrier Reef, all of which survived the worst bleaching event ever recorded. This is a map of the 4 coral sites in the Great Barrier Reef. In May 2004 to 2005, short 50-centimeter coral cores from 90 parietes colonies from 4 reef sites of the central Great Barrier Reef were collected. 2 cores were collected from each colony, and in total 186 cores were collected. All cores were strictly taken from shallow water environments. All cores were prepared using standard techniques such as being air dried, placed on aluminum trays, and 3 6 to 7 millimeter thick slices were removed. Each slice was then X-rayed and moved to a positive print to show evidence of growth characteristics, including luminescence, linear growth, density, and calcification. Luminescence and density were very important, which is why luminescence was measured along each track, even more so intricately, and successive density peaks were dated from the date of collection of each core. Analysis. Abnormalities of growth characteristics were averaged by reef for each year and expressed as a percent value change and compared in 1986 to 1997, which was turned into a percentage. Linear regression analysis was conducted for annual extension, density, and calcification rates for each site, because those were the most important again, and they were expressed in bar graphs and plot charts. Data and results. These growth characteristics at the 4 different reef sites show the difference between their growth characteristics and the time of the original bleaching, 2010, the time the study was conducted. They show significant differences, and the bars show that the reefs are slowly recovering. The decimals are in place of percentages, and B shows growth characteristics of density, C shows extensions, and D shows calcification, as well as E showing luminescence. Figure 5 shows the growth characteristics abnormalities at each site when compared to the 1998 mass bleaching event. Statistically distinguishable sites are identified by the letters above each bar. More data and results include most notable percent changes occurred in the growth characteristics of calcification and linear extension. Calcification had the highest percentage in Nelly Bay and linear growth in Pandora. Only recently did these Porides colonies start fully recovering. Figure 6 shows the percent change of calcification levels, slowly declining since 1999 and only recently recovering. Figure 7 shows the growth anomalies reported in Porides calcification histories, percentage of coral cores at each reef site showing. The black bar represents percentage in 1998, and gray bar represents percentage in 2010 study. The first image shows the percent in the linear extension, and the second picture shows the percent in growth of calcification levels. Discussion and conclusion. Confirm that thermal stress events, mass bleaching, were recorded in annual growth characteristics. It was found especially in linear extension and calcification percentages recorded between 2004 to 2005. Bleaching in the Great Barrier Reef overall increased from 21% in 1998 to 41% in 2010. Applications will better inform models that project how coral calcification will respond to ongoing warming of tropical oceans, as calcification was the most percent change seen from 1998 to 2002, in a total of 15%. Here are my references and citations, and thanks so much for listening.